Good morning. We have already learned about Kelvin-Planck statement and Clausius statement. Kelvin-Planck statement is for heat engines, and for refrigerator there is Clausius statements. These two are the second statements for the second law of thermodynamics. Today we can see that the Kelvin-Planck and Clausius statements are equivalent. Even though Kelvin-Planck is stated for heat engines in the case of heat engines, and Clausius statement is for refrigerator, but both can be equivalent. So we can prove the equivalence of Kelvin-Planck and Clausius statements. That is, the Kelvin-Planck and Clausius statements are equivalent. So how can we prove that? For that we need some terms. One is K, capital K. This represents the truth of Kelvin-Planck statement. So if Kelvin-Planck statement is true, we can represent it by K. Then capital C, it represents the truth of Clausius statement. If Clausius statement is correct, then we can imply it as C. Then minus K, which represents the falsity of Kelvin-Planck statement. If Kelvin-Planck statement is false, then we can represent that by minus K. Similarly, minus C represent the falsity of Clausius statement. So if two statements are said to be equivalent, when the truth of the first statement implies the truth of the second, and the truth of the second statement implies the truth of the first statement. That means if Kelvin-Planck statement is true, then Clausius statements also should be true. If Clausius statement is true, then the Kelvin-Planck statement should also be true. That is the meaning of the equivalence of Kelvin-Planck and Clausius statement, or any two statements. Similarly, if we can take the falsity of both the equations, like when the two statements are said to be equivalent when the falsity of the first statement implies the falsity of the second statement, and the falsity of the second statement implies the falsity of the first statement. That means if Kelvin-Planck statement is false, then Clausius statements also should be wrong. And if Clausius statement is wrong, then the Kelvin-Planck statement should also be wrong. If one is correct, then the other should also be correct. That is the meaning of equivalency. So we can represent, we can use different symbols here. That is, for equivalence, we are taking this symbol. This is not equal to, this is equivalent to. So this symbol represent equivalent to, and this symbol represent implies. This is representing the implies, that here it means K implies C. Here it means K equivalent to, or equivalency of K and C, or K is equivalent to C. So we have to prove K is equivalent to C. When we can say K is equivalent to C? If K implies C and C implies K. That means if, what is K? It is the truth of Kelvin-Planck statement, and C is the truth of Clausius statement. That means if the Kelvin-Planck statement is true, that implies the Clausius statement also be true. If Clausius statement is true, that implies the Kelvin-Planck statement is also be true. So we have to prove K equivalent to C. For that we need to give, or we need to prove K implies C and C implies K, or if minus K implies minus C, that is minus K. Minus K is the falsity of Kelvin-Planck statement, and minus C is the falsity of Clausius statement. Then if Kelvin-Planck statement is wrong or false, then Clausius statement also should be false. If Clausius statement is false, then Kelvin-Planck statement should also be wrong. That means minus K implies minus C and minus C implies minus K. Then we can say that K is equivalent to C. Either we have to prove K implies C and C implies K, or we have to prove minus K implies minus C and minus C implies minus K. Either one we have to prove, either this or this we have to prove. So here we are taking the falsity, using the falsity of the statements, we can prove K is equivalent to C. How can we prove that? We have to first take minus C implies minus K. Then next we have to prove minus K implies minus C. Minus C implies minus K. We have to first prove this one. So what is minus C? So what is minus C? It is the falsity of Clausius statement. So we are first consider the Clausius statement a false statement for Clausius. That means we are taking a refrigerator. It is not working in accordance with the Clausius statement. We are considering a refrigerator that is working against the Clausius statement. That is minus C. So what is Clausius statement? Clausius states that it is impossible to construct a refrigerator operating in a cycle will produce no effect other than the transfer of heat from a lower temperature reservoir to a higher temperature reservoir. That means the impossibility of transfer of heat from a lower temperature to a higher temperature reservoir without doing an external work. So in order to transfer a heat from lower temperature reservoir to a higher temperature reservoir, we have to do some work on the system. So that is the Clausius statement. So here we are dealing the falsity of Clausius statement. That means we are transferring some quantity of heat from lower temperature reservoir to higher temperature reservoir without doing any work on the system. That means here the Clausius statement is false, or this refrigerator is working in contradiction to the Clausius statements. We are not doing any external work to the system. So that is negative C that we are taking. So we have to prove if C is false or the Clausius statement is false, then Kelvin-Planck statement also should be false or also should be wrong. How can we prove that? Here QL amount of heat is transferred from the low temperature reservoir to a higher temperature reservoir. And we are considering another, we are considering an engine which is also working between the two same reservoirs. Here, the heat engine is taking QH quantity of heat and doing some work, and the remaining quantity of heat is rejected to the low temperature reservoir. This we are considering a heat engine. This is now working correctly. There is no violation of the Kelvin-Planck statement. Here, violation of Clausius statement. Here, now there is no violation. If you are considering this heat engine as alone, then there is no violation of the Kelvin-Planck statement. But consider this system as a self-contained machine. Self-contained machine means this machine, this refrigerator and heat engine together. Let the refrigerator and the heat engine constitute a self-contained machine. Self-contained machine means all are there in the same system. That means refrigerator is there, heat engine is there. So it is a self-contained machine. So what will be the net change in the high temperature reservoir and low temperature reservoir? If these two are considering as together, then we have to consider the total change in the high temperature reservoir and the total change in the low temperature reservoir. So what is the change or what is the net heat taken from the high temperature reservoir? What is the net heat taken from the high temperature reservoir here? Here QH quantity is taken from the high temperature reservoir and the high temperature reservoir got equal quantity of heat. So net heat taken from the high temperature reservoir is QH minus QL. That is, net heat taken from the high temperature reservoir is, it is QH quantity is taking and it receives QL quantity of energy. So net heat taken from high temperature reservoir is QH minus QL. QH minus QL quantity is taken from the high temperature reservoir. So what is the change in the low temperature reservoir? Here the refrigerator, it transfers QL quantity of heat, but at the same time low temperature reservoir receives QL quantity of heat. So what is the net heat transferred to the low temperature reservoir? That is, it is getting QL quantity and it is giving QL quantity. So net heat transferred is 0. So net heat transferred to the low temperature reservoir is QL minus QL, which is equal to 0. Then what does it mean? From the high temperature reservoir, we are taking QH minus QL quantity of heat. There is no heat transfer to the low temperature reservoir now if we are considering a self-contained machine. So what will happen? This QH minus QL quantity of heat is completely transferred into work. That is the violation of the Kelvin-Planck statement. What is Kelvin-Planck statement? Kelvin-Planck statement states that it is impossible to construct a heat engine working in cycle will produce no effect other than the transfer of heat from a high temperature reservoir and performance of equivalent amount of work. That means it is not possible to construct a heat engine that is having 100% efficiency. That is, the heat taken from the high temperature reservoir cannot be completely transferred to work. Some quantity of heat should be rejected to the low temperature reservoir. That is the Kelvin-Planck statement. But here what is happening? There is no net heat transferred to the low temperature reservoir, but there is a net heat taken from the high temperature reservoir. That implies this amount of work is done there, or the heat taken from the high temperature reservoir is completely converted into work without any change in the low temperature reservoir. That means the Kelvin-Planck statement is violated. Then we can say we are taking, first we are considering the refrigerator is violating the Clausius statement. Then what we are getting, the Kelvin-Planck statement also false. That implies minus C implies minus K. The falsity of Clausius statement implies the falsity of Kelvin-Planck statement. First we are considering the refrigerator, that is violating the Clausius statement. We are not doing any work. We are considering the heat engine which is working well, there is no violation of the Kelvin-Planck statement at first. But these two can be considered as a self-contained machine. That means these two can be considered and doing or performing some processes together. So in that, the total or the net heat transferred from the high temperature reservoir is QH minus QL, and the net heat transferred to the low temperature reservoir is QL minus QL. That means 0. That implies there is no change in the low temperature reservoir. Then that is the violation of, without transferring any energy to the low temperature reservoir, self-contained machine is working. So it is a complete violation of the Kelvin-Planck statement. That means minus C implies minus K. Okay. So next we have to prove, for equivalence, to consider Clausius and Kelvin-Planck statement are equivalent, we have to prove minus C implies minus K. That we have already done. Then we have to perform minus K implies minus C. For that, we are taking the Kelvin-Planck statement, or we are considering a heat engine that is violating the Kelvin-Planck statement. Then we have to prove the Clausius statement is false. For that, we are considering the minus k here. What is minus k? There is no change in the low temperature reservoir. That means there is no heat transfer to the low temperature reservoir here. That means from the high temperature reservoir, this heat engine, this is the heat engine here. This is taking QH quantity of heat and it is performing or it is converting the this QH completely into work without any transfer to the low temperature reservoir. This is the complete violation of the Kelvin-Planck statement. If Kelvin-Planck statement is true, then there should be some quantity of heat rejected to the low temperature reservoir, that is QL. Here we are considering the violation. That means the engine is violating the Kelvin-Planck statement. That implies QH quantity is taken from the high temperature reservoir and it is completely convert this QH into work. Next we are considering a refrigerator that working in between the same two reservoirs. So here the refrigerator is not violate here the refrigerator is not violating the Clausius statement. That implies it is taking some QL quantity of heat by performing some work. The W is the work given to the low temperature given to the system. So the system transferring some quantity of heat from the low temperature reservoir and together with the W work done, it is transferred to the high temperature reservoir. Here work is, we are considering the work given by the heat engine. So this work can be represented by QH because this QH is completely converted into work here because it is a violation of Kelvin-Planck statement. So we can consider W as QH. So here with the help of this work done or with the work output by the heat engine, we are taking QL quantity of heat from the low temperature reservoir and QL plus W to the high temperature reservoir. Here W is equal to QH. So QH plus QL quantity is rejected to the high temperature reservoir. Here there is no violation of the Clausius statement, but here it is the violation. So next we can consider these two together as a self-contained machine. That means these two are working together under the same, between the same two reservoirs. So these two constitute a self-contained machine. Both are here, heat engine and refrigerator is here. So the work given by the heat engine can be utilized by the refrigerator. So if you are considering the self-contained machine here, so what is the net heat change in the high temperature reservoir and net heat change in the low temperature reservoir? You can see that the net heat transferred to the high temperature reservoir is, here QH is taken from the high temperature reservoir. Here QH plus QL is given to the high temperature reservoir. So net heat transferred to the high temperature reservoir is QH plus QL minus QH. So QH plus QL is given, or it is having QH minus QH plus QL heat is given to the high temperature reservoir and QH quantity is taken from the high temperature reservoir. So net heat given to the high temperature reservoir is, that is QH plus QL minus QH, that is QL. Net heat transferred to the high temperature reservoir is QH plus QL minus QH, that is QL. So what is the net heat taken from the lower temperature reservoir? That is QL. So that is QL. That means QL quantity of heat is taken from the lower temperature reservoir and the same is transferred to the higher temperature reservoir. There is no other net effect. There is no other net effect here. QL quantity is taken from the lower temperature reservoir and QL quantity is rejected to the high temperature reservoir. That is the violation of Clausius' second law of thermodynamics. That means here transfer is occurring, but there is no other effect here. So it is a violation of Clausius statement. If Clausius statement is true, then there should be some work done on the system to transfer heat from a lower temperature reservoir to a higher temperature reservoir. Then the higher temperature reservoir should get more energy than the heat extracted from the lower temperature reservoir. That means higher temperature reservoir will get QL plus this W amount of energy. Here nothing like that is happening. So that is the violation of Clausius statement of second law of thermodynamics. Here QL quantity of heat is taken from the lower temperature reservoir and the same is transferred to the higher temperature reservoir without any change elsewhere. This is the violation of Clausius statement of second law of thermodynamics. That means minus K implies minus C. So we have proved minus K implies minus C and minus C implies minus K. That means we can say K is equivalent to C. That is, the Kelvin, Planck and Clausius statements are equivalent. So first we are taking minus C, that is we are considering a refrigerator which is violating the Clausius statement, and we have proved that it also implies minus K, the falsity of Kelvin-Planck statement. In the second case, we are taking the falsity of Kelvin-Planck statement. We have considered an engine, a heat engine that is not transferring any heat to the lower temperature reservoir, a violation of the Kelvin-Planck statement. Then we have proved that this minus K also implies minus C. That means falsity of the Kelvin-Planck statement implies the falsity of Clausius statement. Since minus K implies minus C and minus C implies minus K, we can say that K is equivalent to C. That is, the Kelvin, Planck and Clausius statements are equivalent. One statement is given for the heat engine and other statement is given for the refrigerator, and refrigerator which is working in opposite cycle that of the heat engine. Even though it is working opposite to that of the heat engine, or the cycle is opposite to that of the heat engine, both the statements for second law of thermodynamics given for heat engine as well as for Clausius statement for refrigerator are equivalent. So we can stop now. Thank you.